Our today's topic, decimal to binary, octal and hexadecimal conversions at a glance. We have already discussed all sorts of conversions. Today we will discuss at a glance the conversion from decimal number to binary number, decimal number to octal number and decimal number to hexadecimal number. In general, for conversion from decimal to any number system with base R, the following operations are performed. For integer or whole numbers, repeated division by R. For fractions, repeated multiplication by R. If R equal to 2, it is binary. If R equal to 8, it is octal. If R equal to 16, it is hexadecimal. Sometimes the word radix is used in number systems. It is a synonym for the word base. Let us convert the decimal number 100.25 into binary, octal and hexadecimal number. Here the integer part is 100 and the fractional part is 0.25. Let us first convert this number into binary. For integer part, we have to perform the repeated division by 2. Here, performing the first division operation, we get 0 and it is our LSB. Next, performing the division operations, we are getting the remainders as mentioned here. We are writing that remainders here in the right side, and finally we get remainder as 1, which is our MSB. Next, read up. So we get 1100100 as the binary equivalent of decimal 100. Next, for fractions, we have to perform the repeated multiplication by 2. Here, performing the first operation, we get 0.50 and this 0 is our MSB. Performing the second operation, we get 1, which is our LSB. Next, read down. So 0.01 is the binary equivalent of decimal fraction 0.25. Hence, 1100100.01 is the binary equivalent of the decimal number 100.25. Next, decimal to octal conversion. Here also for the integer part, we have to perform the repeated division by 8. After first division, we get remainder as 4 in decimal, which is also equivalent to 4 in octal system, and it is our LST. After second division, we get also 4 as the remainder, and after third division, we get 1 as the remainder, which is in decimal system, and it is also equal to 1 in octal system, and it is our MSD. Next, read up. So 144 is the octal equivalent of decimal number 100. For fractional part, we have to perform the repeated multiplication by 8. After performing the multiplication operation, we get 2.00. Here, this 2 in decimal system is also equal to 2 in octal system. So 0.2 is the octal equivalent of decimal fraction 0.25. Hence 144.2 is the octal equivalent of decimal number 100.25. Next, decimal to hexadecimal conversion. Here also, for the integer part, we perform the repeated division by 16. After first division, the remainder is 4 in decimal, which is equivalent to 4 in hexadecimal system. It is our LST. After second division, we get remainder as 6 in decimal, which is equivalent to hexadecimal 6. It is our MST. Now move off. So 64 is the hexadecimal equivalent of decimal number 100. Now for fractions, we perform the repeated multiplication by 16. Here, performing the multiplication operation, we get 4.00. This 4 in decimal system is equivalent to 4 in hexadecimal system. So 0.4 is the hexadecimal equivalent of decimal fraction 0.25. Hence 64.4 is the hexadecimal equivalent of decimal number 100.25. For more details, again we have to continue to number system lecture 16. Thank you.